This video will be on adding and subtracting polynomials and multiplying polynomials. So when we add polynomials, a polynomial is just a two or more term sentence, alright, and we're going to go, we have three here, so we call this a trinomial plus a trinomial. But really when it's add in the middle, you just kind of drop the parentheses and collect like terms. So we've done this before. 3b squared plus 7b squared is just 10b. Sorry, I said that wrong. 3b cubed plus 7b cubed is 10b cubed. So you can only add like powers, okay, and like variables. It looks like we have a negative b to the fourth by itself. I should put the highest term first, alright, and then looks like I have a b squared that's by itself, and then after that I have two constants. I have 4 plus negative 8, which is negative 4, and that's it. So this is really simplifying an expression with different terms. Alright, so you can only collect like terms when you're talking about that. And then the only thing that changes when it's subtraction, and we've done this before also, is that you have to make sure that you think of that as like a negative 1. Alright, you're subtracting every single thing in here, so it's like each one of these turns negative. Alright, so 6 minus 5x minus 7x to the third minus 7 minus 7x to the third and minus 6x. So I'm distributing a negative 1 to every single thing inside of there. From there I'm going to collect my like terms. So it looks like I have negative 14 x cubed. So I put those two together. Then I have a negative 6 and a negative 5, so that's negative 11x. And I have 6 minus 7 is negative 1. So not that much different than you've seen previously. I'm going to do one more subtraction for you. So again, I'm going to distribute this negative sign to each one of those terms. Now it just so happens that the last one, all of them were positive. Now this one, every single one is negative, but just a coincidence. So when I subtract a negative, that becomes positive 8n cubed. That's really what you're doing. So, you know, distribute a negative times a negative is a positive. Be positive 8 and positive 2n to the fourth. So looks like those two are like, so 7n to the fourth. You know, some of you guys do that, you put boxes around it. You have negative 3 plus 8, that's positive 5n cubed. And then these two make positive 5n. And we are done. So again, just a reminder, if you're going to add these two, you drop all of your parentheses and just add. So that's 11k to the fourth. This doesn't collect with anything, so you just rewrite. Those two there make 9k squared plus 2. Alright, so that's adding and subtracting. We're going to get on to, those are my notes, multiplying polynomials. And you've already done this. A binomial times a binomial, we used FOIL. Alright, and really anytime you multiply a polynomial, even when it has three terms, you do kind of a FOIL method to multiply polynomials. So basically everything inside this first parentheses you must multiply to the second parentheses. So when you've been foiling, you're taking the 3n times the 2n and the 2. Okay, so that makes 6n squared plus 6n plus 4n. Oops, I got ahead of myself. I got to do 2 times 2n, and 2 times 2 makes 4. Alright, so when you're foiling, you're multiplying this 3n to each term and the 2 to each term. So two binomials multiplied together, you end up with 4 terms, but the middle terms are going to combine. Alright, so you have 6n. So this is nothing new to you guys. You FOIL that like you always have. This one got a few people before because it's squared, but remember, what does that mean? We just got done doing exponents. It means multiply this quantity to itself. Now there's a shortcut here, but you can always, when in doubt, FOIL this thing completely out. And 7k times 7k is 49k squared minus the 7k. Then multiply -1 to each one. So I'm going kind of fast because I know you guys are good at this. Put those two together, you get -14k plus 1. The trickiest part is just remembering to rewrite this twice. You cannot, and I repeat, you cannot just do 7k squared minus 1 squared. That does not work. Alright, so that's simple multiplying. But if you turn to the next page, alright, I'm going to do 25 and 26. It's a little different, okay? So you have a binomial, 2 terms, times a trinomial, which is 3 terms. So it looks a little different. You're used to seeing a 2 term by 2 term, but the only difference, only thing that changes here is that you have to distribute kind of, this 3r to all 3 terms. Alright, so think about it. If I do 3r times 7r squared, I get 21r cubed. 3r times 2r is 6r squared, and then 3r times 1 is just 3r. So just by doing that once, I'm going to end up with 3 terms here. If I do it again with the -1, okay, so you can maybe call this like super foiling or something. You're just foiling it kind of 3 times versus twice. So -1 times 7 is -7r. It's going to be -7r squared. -1 times 2r is -2r, and -1 times 1 is -1. So when you get done foiling this thing out, distributing each term, you should end up with 6 terms. Alright, now it's not going to stay 6 terms because we can collect what we can. So it's like the cubes by itself. Those 2 squareds make -1r squared. Put those 2 together, you get +1r minus 1. And then you're done. Okay, let's show another one. Again, you guys are going to use the arrows most likely. You're going to multiply r to all 3 terms. So that's going to be 5r cubed plus 4r squared. R times 4r. R times 6 is 6r. So there you go. I end up with 3 terms. If I do it again, I'm going to end up with 6 terms before I simplify. So I'm multiplying by +1, so really I'm just going to get exactly what was in there. Each one of these multiplied by 1 is itself, so I just kind of rewrote it quick. Alright, so again, I have 6 terms. It's going to end up being 4 terms. Those 2 make 9r squared. Those 2 make 10r. And then we have a 6 at the end. Alright, so you guys can practice the rest of those. I think you'll get that pretty quickly. Alright, I wanted to show 36 just because this one looks a little bit different, but if you think about squaring this, it's going to end up being a trinomial. Alright, and it also, you have the trinomial on the left side, and so how would you do this? Well, you think about multiplication, like for number 37, you can switch this around. Multiplication is commutative, so you can just rewrite it like that, and we're back to looking like the previous problems. So that's what I'm going to do in this case. So, but for this, I have to actually expand 2x plus 1 squared, which is 2x plus 1 times 2x plus 1. And when you FOIL this all out, you get 4x squared plus 4x plus 1. Okay, so I didn't show every single step there, but I just FOILed it out, and this becomes this trinomial. Okay, so and now we're back to what 37 looks like exactly like this. I have a trinomial times a binomial. So you may be wondering, well, can I still do this without flipping these two? And yes, you can. You could do 4x squared. You could just distribute that, all right, twice. So you would get 32x cubed minus, because 4x squared minus 1 or times negative 1 is negative 4x squared. And then you could take the 4x times both terms, and you get plus 32x squared. And 4x times negative 1 is negative 4x. And then this is why I like to rearrange it, because it's kind of hard to draw arrows another time doing it this way. So, but you're multiplying by 1. 1 times 8x is 8x. And then 1 times negative 1 is negative 1. So I still end up with 6 terms, just like I did before. It's just a little bit different way of doing it. I guess you could draw your arrows again up top or something like that, but it just looks a little bit sloppier. But anyways, put this together. Kind of running out of room here, but we'll get it. Put these two together, it looks like you get positive 28x squared, negative 4x, and positive 32x squared. Put those together. Put these two together, that's positive 4x minus 1. And there you go. Okay, so there will be a second video on this going into problems like 41 through 48.